So I'm going to do one problem using the technique of half reactions in order to balance the redox equation. Most of the time in the course I recommend using the method of finding oxidation numbers and balancing that way. But the problem you encounter here is if you look at this particular equation, you only have one reactant, so you can't really deal with two different reactants. So you're forced to use a different method, and so that's why we're going to use the half reaction equations to do this. So copied out of your textbook are the rules here, although I don't think they're particularly helpful because here it says balancing redox equations, and the first thing it asks you to do is to write out the half reactions and separate them, and that's actually a little bit tricky. And over here, how to write the half reactions, I don't think it's very helpful at all because it says, write the chemical formulas for the reactions and products and balance everything. And I think it's a little bit overly simplified. So anyway, if we take a look at this equation, you've got to realize that since you've only got one reactant, there has to be something a little bit different happening than if you have two reactants. And what that is that, first of all, there's only chlorine and oxygen atoms involved here, okay? There is no peroxide, so oxygen is always going to be -2 in each of these situations. But chlorine, in one situation, chlorine is going to get oxidized, and in another situation, chlorine is going to get reduced. And so, in attempting to write out my half reactions, I wrote the only reactant there is, which is OCl- over here, but for the first half reaction, I wrote Cl- as the product, and in the second one, I wrote ClO3-. Then I took a very close look at all the oxidation numbers. And in fact, I found that chlorine, and over here you have to solve for chlorine, okay? X minus 2 is equal to -1. And so you find chlorine to be +1. Here chlorine has to be -1. So in this situation over here, chlorine is undergoing a reduction, okay? It's gaining 2 electrons. And in this situation over here, chlorine goes from +1 to +5, and you've got to solve for chlorine oxidation number over here. So in this case over here, chlorine is undergoing an oxidation. Loss of electrons is an oxidation. And so it is losing 4 electrons. Okay, +1 lost 4 electrons becomes +5. All right, so this is the hard part that we've done over here. And now we can sort of follow these rules over here, okay? And basically what's involved is if we take a look at the waters, okay? On the top over here, we need to add 1 water on the right side because we have an oxygen over here. And on the bottom equation, we've got 3 oxygens and only 1 over here. So we need to add 2 waters over here. Okay. Now, I should have actually mentioned that this problem from your textbook over here, this is occurring in basic solution. Okay, but as with balancing by oxidation number, we'll deal with that later. First, we deal with it the way we always do, and then when we notice that it's basic, we have some extra steps. So anyway, so now if you take a look at this top equation, okay, to balance the hydrogens, we need 2 H pluses on this side, and over here we have 4 hydrogens here, so we need to add 4 H plus on this side over here. And at this point, we would be done, except for we realize that it's basic, and so we need to add 2 OH minus on this side over here. And when we do one thing to the left side of the equation, we have to do the same thing to this side of the equation. Okay, and so over here we've created 2 waters. So we'll cross these out and we'll write 2 waters. But there's already a water here, so I'll switch pen colors, we'll cross out this water, and that makes there be just 1 water on the left. And down here, we've got to neutralize the 4H+, so we're going to add 4OH-, okay, and that's going to create 4 waters on the right side, but we have 2 waters here, so instead of there being 4 waters on the right, we end up with just 2 waters on the right. So now it's just a matter of rewriting this whole thing neatly. But actually, before we do that, there's one other thing we need to do, and that is if there's 4 electrons on the right side over here and only 2 electrons on the first equation, this whole first equation is going to have to be multiplied by 2. So now this maybe gets a little bit confusing, but all we have to do is add these equations. Okay, we add them the way mathematically you add equations, and follow along here. I'll cross things out. Okay, this whole top is being multiplied by 2, so there is 2 waters, because 2 times 1 is 2 waters on the left, and there is 2 waters on the right, so the waters are gone. There is 2 hydroxide times 2 for a total of 4 hydroxide over here. And now I realize that when I added 4 hydroxides on this side, I actually forgot to add 4 hydroxides on this side. So there they are. So these 2 times 2, 4 hydroxides cancel these 4 hydroxides. And so actually, since the water and the hydroxides canceled, all we're left with is 3 OCl minus. On this side, 1 times 2 is 2 Cl minus, and 1 ClO3 minus. And this is the final answer after all that work. Okay? And the reason we have 3 OCl minus is because 1 times 2 is 2, plus 1, for a total of 3 OCl minus. And there's our balanced redox equation.